Today we will learn how to write the electronic configuration of an atom using the 1s notation. So the first step here is introducing you to the energy levels. As we can see, if you look at this figure in here, we can see that we started with 1s, and after filling the 1s, we jumped to the 2s, and after the 2s, we jumped to 2p, and after 2p, we go to 3s, etc., etc. But we have to ask you a question. What is the maximum capacity of the s orbital? What is the maximum capacity of p orbital? The s subshell has a maximum capacity of 2 electrons. For p subshell, it has a maximum capacity of 6 electrons. It cannot hold more than 6 electrons. And for the d orbital, it has a capacity of up to 10 electrons. And for the f orbital, it has a capacity up to 14 electrons. Okay, so how can I write the electronic configurations for an atom? What I actually need is the periodic table and memorizing the sequence of those notations. Like you start with 1s, and then it's followed by 2s2, and then 2p, and then 3s, etc. I will explain every single detail in here. So let's take an example of an atom in here. Let's take, for example, sodium, Na. Since we start with 1s, then we have to start with 1s2 because the maximum capacity of s is 2 electrons. Put in your mind, sodium has 11 electrons. And then after the 2s, we have to go to the 2s in here, 2s, and the s orbital occupied by 2 electrons. And after the 2s, we go to the 2p in here, and it has a capacity of up to 6 electrons, and we fill it. And so far, if you count the number of electrons that we already filled, you have 6 in here, and 2, and 2. The overall is 10 electrons, but we need to fill 11 electrons, and that's why we need one more electron. So after filling the 12 electrons, what is the next one? Here we go to the 3s, and how many electrons we need actually? We need only one, and that's why we write 3s1. So if you count the number of electrons in here, 1 plus 6 plus 2 plus 2, then the overall is 11, and that's why this is the best way of representing to write the electronic configuration. Let's take, let's say, an atom with more electrons. Let's take chlorine, for example. It has 17 electrons. Cl, it has 17 electrons, as we can see. Let's follow the graph in here. Let's follow it. We have 1s2, 2s2, 2p6. So far we have 10 electrons. And after that we have 3s2, then we have 12. 3s, we have to go to 3p. But how many electrons we need? Actually, we need 5 electrons. So if you count the number of electrons here, 5 plus 2 plus 6 plus 2 plus 2, all of these will be equal to 17. That's why this is a good thing in here. Yeah, everybody's happy. Let's take another one in the middle of the periodic table, which are the transition elements. Let's take iron, Fe, 26 electrons. Actually, we have a story in here. Okay. We have 1s2, 2s2, 2p6 electrons, and then after that we have 3s2, 3p6. How many electrons are filled so far? We have 18. But you have to look at the graph in here. After the 3p, what should we do? After the 3p, we have to go to 4s. Okay, and that's why we have to go to 4s. But you have to leave a gap in here, and just like 4s here, and fill the 4s at this point, because the 4s has lower energy than the other one. Why did we leave a gap in here? Because we have to put the 3d, and you can see that the 3p here is filled, and after the 4s we have 3d to be filled. So we have to put 3d in here. But how many electrons should I put in the 3D area? You have to find the number that makes it 26. So since here you have 10 electrons, here you have 8 electrons, and here you have 2, then the overall is a 20. Since we need 6 electrons, then this is a 3d6. Put in your mind, guys, we fill, just like it's a very important note in here, we fill the 4s before the 3d. This is an alert for you. You have to fill the 4s before the 3d because, like, imagine those are like energy levels. The 4s here is occupied by those electrons before the 3d, because the 3d has ability to occupy 10 electrons, which is higher in energy, and that's why it's higher than the 4s. But you have to write the 3 numbers together, like 3, 3, 3 together, 4, 4, 4 together, but you fill it first. Let's take another example to make it easier. Let's start with 1s2, 2s2, 2p6, and now after the 2p6, with the time you'll memorize all of these sequences in here, by the way. 2p6 and then 3s2, 3p6. And after the 3p, we have to make a gap in here to write the 4s and fill the 4s in here, and then just go back again to write the 3d in the middle and just write it like the complete number in here. And since you have 2 plus 6 plus 2 plus 6 plus 2 plus 2, all of these are equal to 20, then the missing number is 8. And that's why the D has 3D8. Okay. By the way, if I need to write the Ni positive 2, what does it mean? It means that this atom lost 2 electrons. The positive sign indicates to a loss of electron. The negative sign indicates to gain electron. How can I write the electronic configuration of Ni positive 2? What you have to do is write, just like focus in this point, just like write it. Do what I'm talking about. The first step is writing the whole electronic configuration for the atom. So this is the first step for Ni. And then you have to write it first, like the full, and then just like remove these 2 electrons. Okay, so we remove the electrons from here, from the outer shell. Okay, so you will lose 2 electrons since we have positive 2. Then you have to remove this and just write this thing, the whole thing in here. So you have to say 1s2, 2s2, 2p6, 3s2, 3p6, 3d8. Okay, this is very important. You have to put it in your mind. Okay, write it full in first and then write it again, like without anything else. Okay, but since you're dealing with chemistry, you're dealing with a lot of exceptions. I'm so sorry for telling you that we have 2 exceptions in chemistry in the electronic configurations, and they are chromium atom and copper. This is an exception, and it's really important. We have a lot of questions about it. You have to put in your mind the d orbital likes to have 10 electrons or the half of 10 electrons, which is 5 electrons. And it tries its best to have 5 electrons or 10 electrons. And this process takes place only in chromium and copper. What do you mean? Let's take an example. If I ask you to write the electronic configurations of chromium atom, by the way, it has 24 electrons. We write the electronic configurations as we used to do. So we start with 1s2, 2s2, 2p6, 3s2, 3p6, and we go here for s2 and then 3d4. But we told you that the d orbital likes to be 5 electrons or 10 electrons. How can I make this 4? Because it's close to 5. How can I make it 5? There is a process takes place in here in which the 4s is a generous right now. It will give an electron to the 3d, and that's why the 4s becomes 4s1 and the 3d becomes a 3d5, which is finally happy. And then we write it as it is: 3p, 3s2, 2p6, 2s2, 1s2. And by the way, in your exam, you never ever write this. This is a mistake. This is not true. This is wrong. So this is the the answer that we have to write in the exam if we have something like this. You have to put in your mind, if I ask you to write the electronic configurations for the chromium ion, chromium positive 3, as we told you, you have to write the full electronic configuration, which is the considered one here, the guaranteed one here.
So chromium here lost 3 electrons, and that's why we have to remove an electron from the 4s first, and the 4s is gone. And 2 electrons from 5, and that's why it becomes the 3d3, and then we just write the whole thing as it is, like 3p6, 3s2, 2p6, 2s2, and 1s2. So this is the electronic configurations for of a chromium positive 3.
It has a 29 electrons. We write the electronic configuration. We have 1s2. We have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d9. And at that point, you feel like it's the same story. The D likes to have, the D likes to have 10 electrons. We have a probability to have electrons. The same story is repeated with 4s. It donates an electron to this one here. And that's why this one becomes 4s1 and 3d10, etc., etc. And that's why this is the recommended one to write in your exam if you were asked, and this is not the true one. This is wrong, totally wrong, forget about it. And the same matter if I ask you to write the electronic configuration of copper ion. We write the full electronic configuration first and then remove the 2 electrons from here. So since we remove 1 electron from the 4s and 1 electron from 3, then it becomes a 3d9, 3p6, 3s2, and 2p6, 2s2, and 1s2. All right. So this is so far for today. Have a nice day.